Manufacturing is sexy. Sounds crazy? Just wait. I'm Z Holly, host of The Art of Manufacturing. Your behind-the-scenes look at how people who make stuff are trying to make it in their industries. If you've ever wondered how to build a brand, a business, or just a better mousetrap, tune in and enjoy. Imagine if you could accelerate pods of people to twice the speed of an airplane through vacuum-filled tubes. Pretty wild. When Elon Musk first proposed the Hyperloop in 2012, most people fell into two camps, enthusiastic or skeptical. The idea itself is actually more than 200 years old, but it never made headway until Elon's announcement. And since then, several startups have run with the idea. And contrary to common wisdom, he has no direct involvement in any of them. One of these companies, headquartered in downtown LA, attracted a huge investment from Richard Branson recently. They're now called Virgin Hyperloop One, and they were the first to demonstrate the concept on a test track near Las Vegas. And this week, we're talking with their Senior VP of Systems Engineering. Dr. Anita Sengupta started her career working for NASA on pioneering space projects like the Mars rover and the Cold Atom Laboratory. And then Hyperloop One tapped her to coordinate all of the pieces for their very complex engineering puzzle. This episode was recorded live at the Art Center College of Design's Bold Conference. I was curious to hear the variety of challenges she's up against as they bring a once crazy idea to a full production system. I also wanted to learn what it was like to go from a very large governmental organization like NASA to a startup environment like Hyperloop. And we talk about what the innovator of the future might look like and what we all should do to prepare. We hear about that and a whole lot more on this week's episode of The Art of Manufacturing.
What is it like to work for Richard Branson?
It's very different from my prior experience, was just down the street from the Art Center. So it is a startup environment. I probably started around 6 people 4 years ago, and now we're up to close to 300 people. And our headquarters is in downtown Los Angeles. So in terms of what it's like to work for Richard Branson, I think he's an excellent leader. He's a very inspiring leader, and he's all about empowering his people to be able to innovate. So I think that's very positive, and he's a great person to have as a chairman, given the fact that we are trying to innovate the future of transportation.
Yeah, definitely a different angle on it than he's been used to as well. Explain for us all, what is a systems engineer, and what does that role mean for Hyperloop?
So my role at Hyperloop is I'm the Senior Vice President of Systems Engineering and Safety Certification. So I have a team of systems engineers who work as part of my organization and a team of safety and regulatory engineers who work as part of my organization. In terms of the discipline of systems engineering, I think NASA actually invented it. And it's for the design of complex systems. So if you have complex systems where you have different parts that have to function together, function in unison, but you have to design them before you actually have the system built, you use systems engineering principles to make sure that they work. So it's a little bit of a chicken and the egg problem. If you have a very complicated system, if you don't use system engineering practices to understand how things function across the interface, for example, electrical systems, thermal systems, mechanical systems, you won't be able to get it to work and design it up front.
What is the vision for Hyperloop? We hear a lot about it. I think a lot of people are confused by it. A lot of people say, oh my God, it's dangerous. Tell me more about where are we going to be and when?
I guess the best way to describe it is electromagnetically levitated and then electromagnetically propelled passenger pod, and it's inside of a vacuum tube. The reason why it's inside of a vacuum tube is because the primary energy loss mechanism for transportation as you go higher and higher in speed is aerodynamic drag. So if you could put your vehicle inside of a low drag environment where you don't have that much air, you can actually reduce energy consumption. And then because you're using electric motor, you can actually power your system off the grid. So the purpose of it is to provide you high-speed, over-the-ground transportation at minimal energy cost, minimal personal cost in terms of ticket cost, and to reduce the carbon footprint.
I've always wondered, though, why there's all this focus on the passenger transport when you have to be, as society, we have a lot of cargo that we want to transport, and there's a lot fewer safety and other maybe regulatory limitations and requirements on that.
From a systems perspective, we're designing it so that it can handle both cargo and people. And so we had a press release that came out probably about 2 weeks ago about our cargo speed application. But the pods themselves are designed from a payload mass perspective, can handle either cargo or people. And the size of the door that we're using is aligned to fit with the examples of palletized cargo that you would have. So it's for high value cargo that you want to be able to transport over short periods of time over long distances. So it could do either one.
What's the biggest myth that you wish you could dispel about Hyperloop?
I guess probably is how long it would take to get the system regulated. So anytime you do create a new form of transportation, you do have to set of regulations that go along with it. And so ours is best described as a hybrid between an airplane without wings, but which is in a space environment. So it's more like a spacecraft on the ground. So you can actually leverage a lot of the existing regulations from aviation, from rail, and from spacecraft to be able to create a regulatory framework to be able to implement this as a passenger system within the next few years.
And where are you in that process right now?
So in terms of where we are as a company, we have done a full-on technology demonstration. We have a fully operational Hyperloop, which is located about 45 minutes northeast of the Strip in Las Vegas. So we understand how the system behaves now. So we have a really good understanding of how the electromagnetic engine interacts with the levitation motor and interacts with the pod, which is aerodynamically shaped, even though it's in a low vacuum environment. So now the next stage is to apply those regulations to the production vehicle, which then imposes certain engineering constraints, and then to demonstrate that again at speed and then implement it in country.
So when do you think that will actually happen?
So for those of you you are either considering working at startups or creating your own startup, a lot of that is a function of the funding that you have available. And so the more funding you get, the more quickly you can do things. But we're probably going to have it happen within the next 3 years or so.
So I want to talk about the sort of startup environment in a bit, but I want to take a little bit of a step back and talk about your past, because you have a really fascinating career that has brought you here. Tell me first, when did you realize you wanted to be an engineer?
So I've always been a massive science fiction fan. Since the age of 6, I used to watch reruns of Star Trek original series with my dad. I used to watch the old school Doctor Who. So I kind of knew ever since I was a little kid that I wanted to be involved in the exploration of space and hopefully discover alien civilizations. And I think it took me some time to figure out what was the right way to do that, to be an aerospace engineer, to be an astrophysicist, to be an astronomer. But my father was a PhD mechanical engineer, and I realized growing up working with him, fixing the car and fixing things around the house, that the idea of creating and innovating new technologies was the career that I wanted. So that's why I chose aerospace engineering.
You ended up at NASA. Tell us a little bit about maybe the most challenging moment you had at NASA, to sort of paint a picture of what your job was in that context.
Well, I have been fortunate to work on many different projects over my course of my career at JPL. So it's kind of hard to, each one was so unique and each one had an interesting experience. But I would say the two most complicated ones were the development of the supersonic parachute for the Mars Science Laboratory Curiosity rover. And so we had several different failures that occurred during the course of the development of that parachute. And each one of those failures, we had to come up with a solution. So a really interesting one would be, because the environment on Mars is so different on Earth, there's no way to test it in exactly the way that you would fly it on Mars. And so you have to come up with nifty ways of doing or designing test programs which are based off of physics so you can understand how the parachute may perform. And so one of those examples, we would test the parachute out in the desert, take it up to 3,000 feet in altitude, which would then allow you to match the load that the parachute would experience, but not the same aerodynamic environment. And so we did have very early on a failure, and then we were able to figure out what happened. That's the reason why you do testing and engineering, and then make the system stronger so that it would be able to survive the loading environment that it would see on Mars.
So had NASA done that kind of, it sounds like sort of somewhat mix of testing in an analogous environment and simulation mixed together. Is that something that's common at NASA?
It has become more and more common over time just because of the the ability to use supercomputers, for example. So for the supersonic environment on Mars, for the environment on Mars, you actually have to deploy the parachute supersonically just because the atmosphere is so thin. So to produce the same amount of drag area, you have to deploy it at a higher altitude and a higher speed. And so with the advent of computational fluid dynamics, which make use of supercomputers, you can actually do these simulations to understand what the aerodynamic environment is and how that then couples to the structural environment that the parachute feels. And so the more sophisticated simulation techniques you have and the better you can validate them, the more you can rely on those designed by analyses instead of designed by test. So I think definitely the industry as a whole, whether it's automotive, aviation, or aerospace, is trying to leverage as much as they can from design by analysis, validated by test, as opposed to design by sort of test, guess and check.
But if I remember correctly, that was kind of an early pioneering example of that type of testing. I mean, how did you convince them to do it?
It was the first time when they used this type of simulation and then validation by test as a means of qualifying the parachute system. And so my background as a research engineer was to design these test programs and validate simulations. So I used my personal ability to convince people that was the right thing to do in order to save a lot of money for the mission.
Definitely, it's sort of the bottom-up innovation example, right?
Yes, I think so, actually.
Did you have any doubts that it was going to work?
Well, I mean, I think the funny thing is when you work on something which is complicated as a landing system for Mars, you work with a whole team of people, and then you focus on your particular element, and you probably know your element really well, so you have a lot of confidence in your own element, but you may have some, doubts about, well, that looks really hard what my coworker is doing, but you also have complete faith and trust and respect for your colleagues, and so that's kind of like a shared goal and a shared risk-taking between the group of you. But we did everything we could from a engineering perspective in terms of understanding the fundamental physics, understanding the properties of the atmosphere, piecing it together with an end-to-end simulation, basically using the systems engineering principles, that we did everything we could as engineers. And what's fun as a job as an aerospace engineer is that you are doing something for the first time and you're kind of doing the impossible. And it's that sort of wonder of, if this works out, look what we accomplished. So I think I probably always viewed that as a positive thing, not a negative thing.
Something tells me that you're viewing this with 20/20 hindsight. And it's like, oh, yes, of course, it was going to work.
So there are ways to statistically make estimates of what loads are going to be and things like that. And so there's always the chance that you're going to get a bad day on Mars, right, where you're at 6 sigma wind scenario, or you're at a 6 sigma case where the density is thinner than what you designed to. And so those things probabilistically can happen, but they have a very, very low probabilities. But it really is the engineering design space, and it's being cutting edge. And so if you don't take those types of risks, especially for robotic space programs versus so like a human space program, you can't advance the technology. So
I remember my classmates in engineering school. I'm not sure that I would have necessarily always trusted all of their decisions. So what was it like when the Mars rover landed? Tell me about that experience watching this. Nail biting? What was it? Who was around you?
I will say that it probably doesn't really hit you until basically you get the signal that the thing is entering the atmosphere. And then the interesting thing is, because of the time delay between Earth and Mars, it was like let's say roughly 15-minute time delay. And when we actually received the signal, the rover had already landed on the surface because of that time delay. So that kind of hit you like, oh, it's actually already happened. And what we're looking at is what happened back in time. But it was nail biting. I definitely was kind of like shivering a little bit. So just because it was so exciting. But it was an amazing experience. It's just one of those things where, you kind of only get to experience that for the first time, once in your career. And it was transformative for me to be part of something that big.
And then you went from there, on to lead the Cold Atom Laboratory.
But I have an interesting factoid. So the project scientist for the Cold Atom Laboratory is Dr. Robert Thompson, and he actually teaches here at the Art Center College of Design.
Very cool.
So he's a very brilliant person and very kind human being as well.
We want to talk about that for a moment. Why would someone at JPL be teaching at Art Center? Like, I mean, I kind of have my own guesses on this, right? But what is the role of the designer in something like this? This looks like, wow, I can never do that, right? How could we all play a part in really cool future science and technology?
Well, I think innovation is all over the place, right? I mean, you can innovate in music, you can innovate in art, you can innovate in architecture, and then you can innovate an engineering solution to be able to explore phenomena with a scientific basis that you've never seen before. And so there's just so many ways that you can innovate in society and benefit people. Rob, he is an atomic physicist by training, and so he teaches here because he's able to share his sort of visionary theoretical physics view of the universe with, the more artistic set of people that work here. So I just feel as though, science and art is all innovation, and in a sense, it is all human art.
And what do you think that as we all look to the future is changing so fast, how can we play a role? What does the innovator of the future look like, and how do we prepare ourselves to play a role in that future?
So I'm a little bit biased, of course, because I'm an engineer, so I do believe that having a set of critical thinking skills actually allows each of us to innovate in a very different way. So the training that engineering is to be able to teach you to think critically. And it's very different from the standard scientific method where you do make a hypothesis, you design an experiment, and then you test it. Engineering is actually about trying to understand the possible reasons why the thing is happening and do a more targeted design of that experiment. So I think having those critical thinking skills, whether you get it through a degree in engineering or a degree in philosophy, are two different ways of becoming innovators.
Let's get back to Hyperloop. How does that play out in Hyperloop? What kind of people do you have on your team? And how are they using their skills, their critical thinking skills? Maybe an example.
Our team is primarily engineers. The company has, I think, roughly 225 years, and almost all of us are located in downtown Los Angeles. And in terms of their engineering backgrounds, we have a large number who come from aerospace, from the spacecraft world. So SpaceX, NASA, probably some other larger aerospace corporations. And the reason for that is that the Hyperloop itself is actually most akin to a spacecraft than any other form of transportation. We also have many engineers that come from a civil background, because when you're implementing an infrastructure project, there's a huge amount of civils aspect to it in terms of, laying columns along the ground and laying the track and having bridges to go over water and power distribution centers and route alignments. A lot of that is a civil implication. So I think that's the primary disciplines. We also have electrical engineers to focus on the design of our power electronics and mechanical engineers to do structural design. And in terms of how do they innovate, so what's really interesting about startup cultures usually do have a younger set of employees who are, roughly between 3 to 9 years out of their last degree. They have a lot more closer proximity to the analytical tools that they had learned in school and some of the computational tools that they would have used in school. So they're able to apply those very readily. What they don't have is what comes from experience in terms of working in the industry, of knowing what works and what doesn't work, and how to I guess I would describe it as sort of like laying out a full life cycle development for activity. And so that's where you would bring in more experienced people like myself, and you start to bring in more senior leadership so you can lay out sort of a plan on how you would implement something. But then using those visionary engineers is key to being able to be super efficient, actually, from a cost perspective and a time perspective.
So how do you do that successfully? Do you have an example maybe of a situation where you're able to tap into that youthful thinking or different thinking from not necessarily the leadership?
When you are fresh out of school, you would not have been exposed to sort of the bureaucracy that you would experience if you worked at a government institution, for example, where you have to do everything a certain way, and then you would go to the way somebody else did it before, and you would sort of tweak that and modify that. So when you're right out of school, or a few years out of school, you're not actually exposed to that, this is the way other people have done it before, therefore I'll start with that and go from it. You do it exactly how you think you should do it based off of how you see a solution to the problem. And so the way I can give you an example of that at sort of a 100,000 foot level is we built a Hyperloop in less than a year out in the desert of Las Vegas. That's shockingly fast. And everybody on the team did everything from design to fabrication and to going out there and actually setting up the test facility and then running the tests. So the fact that you could do something that complicated in such a short period of time does require a different way of doing things. And that's where the startup mindset and then sort of the VC funded environment enables that.
So do you have that creative abrasion between sort of the two different mindsets, and how do you handle? Because Hyperloop is, I'm sure, has a startup mentality, yet at the same time is larger and is highly funded. And so it has a lot of regulations it has to address. So how do you square that circle?
It's kind of an interesting, because we're now in the transition from being technology to implementing a production system. And so interestingly enough, NASA, believe I created systems engineering principles, also created something called technology readiness levels, which allows you to implement new technology and get to the point where you've de-risked it so that you can implement it into a flight mission or to a spacecraft mission. So I view our demonstration of our DevLoop facility out in Vegas as the full-on technology demonstration, end to end. We've done it in a relevant environment, which is out in the desert with massive temperature strings, and we've also done all of the functioning of the pod vehicle in a vacuum, which is our relevant environment. So now the next stage is actually to implement the regulatory framework and to go in and make the design choices necessary to allow it to fit in with regulations that you would experience around the world for implementing a transportation system, whether that's safety or whether that's the design of doors to accommodate a whole range of passengers, or whether that is the standards that are needed to show that your power electronics will last for several decades. So it's a another level of detailed design that has to occur to allow you to be consistent with that regulatory and safety framework. And that's where you do have to bring in more experienced people who have that background of knowing what that is and knowing the specific processes and procedures that are needed to achieve those things. And that's the stage that we're in now.
And presumably you'd have to bring in people too from more of the, commercial air or trains or, where you have to think about the creature comforts because it isn't just a spacecraft where you have a couple astronauts that are used to being uncomfortable, right? So are you starting to think about that piece as well?
Yeah, so part of my organization actually includes the safety and regulatory. And so my safety and regulatory director, for example, comes from rail, his background in rail. And then the regulatory manager comes from aviation, where he would certify new aircraft. I myself am a pilot. But what you actually can do is you can leverage existing standards, which, like, for example, maximum accelerations and decelerations. There is a standard which exists for people movers at the airport where you're not wearing a seatbelt. That happens to be 1/4 of a G. So not 1 G, but 1/4 of a G. So as long as you design your passenger comfort levels to something which is 1/4 or G or less, then you, by definition, are already meeting the whole range of passenger comfort needs that have already been assessed by other people. So the other thing about being in a cost-constrained environment and doing things quickly is you don't reinvent the wheel if you don't have to, right? So if you could leverage something which already exists, you should do that because it will save you time and money. So we don't have to create a whole new set of passenger comfort standards. We can use ones that already exist and make sure that we're compliant with them. In some cases, make them better. Like, so for example, a Hyperloop doesn't have to go down a runway and feel the bumps. A Hyperloop doesn't have to experience the turbulence that you would experience if you're in an aircraft because your pod, although pressurized, is surrounded by a vacuum. So in many ways, our passenger comfort experience is by definition better.
You're listening to The Art of Manufacturing. Follow our adventures on Instagram and Twitter @ArtofMFG. And to chat with other like-minded creators, join the Art of Manufacturing Facebook group. We'll be right back after this break. I want to give a shout out to DLA Piper, a global law firm with lawyers throughout the U.S. and across the globe, and clients ranging from emerging companies to multinational enterprises. I'm a fan of DLA Piper because their team has been really generous in supporting the Art of Manufacturing, and the Make It in LA initiative is a founding partner. And they've always had someone on their team who's knowledgeable about whatever off-the-wall issue I throw their way. For more information, visit makeitinla.org/DLA Piper. We're speaking with Dr. Anita Sengupta, Senior VP for Virgin Hyperloop One. There's a lot of different companies that are trying to commercialize this Hyperloop, right? So Hyperloop One is one of them. But also, it's not necessarily a new idea. I mean, I remember decades and decades ago, there was some early ideas, and even I think Jules Verne's son had come up with some concept. So what is new now that enables it to happen, and why is this different?
Well, my first exposure to the Hyperloop was with the Jetsons cartoon, which is George Jetson, I think, being pushed through tubes, from city block to city block. And
this is the benefit of science fiction, right? As you can see into the future.
Exactly. Yeah, science fiction does serve as a basis for imagination of an author, and then people converting that into technology, like, for example, flip phones or iPads, which are similar to what we used to have in the Star Trek Next Generation. But in terms of what is different about the Hyperloop, so what is unique is that now a bunch of technologies exist which didn't exist before. The primary propulsion system, for example, is a linear electric motor. A linear electric motor is just a spread out version of a rotational motor. It's powered by batteries. And so battery technology has gotten better and better. And because of the advent of electric cars, battery technology in terms of amount of energy storage capacity per unit mass keeps on going up, right? So that facilitates you to be able to have these transportation systems using new technology. Another example would be moving at speeds of, up to 700 miles an hour, which is in excess of an aircraft. What we're designing to with the Hyperloop requires that the system be fully autonomous. And so all of the technologies which have been developed already by the automotive industry for autonomy in cars, we can readily use and implement. And it's actually a simpler system because you're in a controlled environment. There's no dog or cat which is going to run in front of your vehicle. Also, it's a single direction of motion, so it actually makes it a lot easier. Because of the advent of new technologies, both in software and hardware across the board, you can implement a Hyperloop now more readily than you could have in the past.
What else are you really excited about in the future of transportation? Do you see other trends that are going to complement what's happening with Hyperloop? Because obviously Hyperloop is not good for every kind of situation, right?
Certainly. So I think Hyperloop uses battery technologies, uses power electronic technologies, uses autonomous technologies. It has a front-end software application which allows it to link in with other modes of transportation. So what's unique about a Hyperloop is that it's not like a rail system where you have to wait every 2 hours to get on your train. It's actually on demand because you can view these small passenger pods as sort of like bubbles moving down in a stream, right? You can actually call one with your phone, with the app, connect you to the Hyperloop, get to your destination, and then already have connected to an Uber or a Lyft or a bus on the other side. It's more akin to cars on a freeway where they get onto the main freeway and then they exit a station to get to their final destination. And then anyone at the other destination who wanted to go from point B to point C would then get onto the freeway and go to the next location. So it's a more seamless experience. And one of the biggest inefficiencies associated with mass transportation is what we call the first mile, driving to the airport, walking to your gate, taxiing from the gate to the runway. That actually consumes almost, if you're going to San Francisco, 50% of your journey time. So with a Hyperloop system, which is by definition can be within the city center, right, because it connects to a metro system, you can actually reduce that entire first 2 hours of that journey, and you're only limited to the travel time at that peak speed.
What is the one thing, maybe technological, maybe something else, that keeps you up at night about bringing this to market?
Keeps me up at night. I think because when you are in a smaller company environment, it's probably being able to continue to get the funding. And then I think there's also the challenges associated with making sure that you can meet everybody's regulatory framework around the world, right? So we want to implement the system in India, in the Middle East, in Europe, in the US, and each one of those municipalities and countries have their own very unique needs. So my organization's responsibility is to be able to take in that entire set of requirements from all of these countries all over the world and make sure that we come up with a system which is compliant with all of them.
How big is your government affairs group?
It's a startup, so not that big.
So it is a startup. Your past career has been in much larger organizations. So tell us a bit about what it was like to jump into this startup environment, and what was the biggest surprise, and what could we maybe learn about that?
Well, one of the biggest challenges actually is you just don't have that internal infrastructure, right? Your IT department is a single person. So I'll give you a great example. This is so funny. Like, I have dropped my iPhone, I don't know how many times, my prior job, like, I dropped it. I drop it off at the IT center and I come pick it up the next day. Here it's like, you can drive to downtown and go to I Break You Fix. So I had to drive to downtown, park in the Ralph's, buy some tomatoes from Ralph's so I could actually park at the Ralph's shopping center, walk over to I Break You Fix, drop it off, do that all within 30 minutes or whatever the minimum limit was for parking. So not having that infrastructure actually is difficult. And so you don't really realize it. And then another, more engineering example would be, work at a place like NASA. You have access to all of the actual standards, right? From IEEE, SAE, right? There's a database you go into, you log in, you get it. We don't have that. We have to purchase everything ourselves. So that makes it more difficult just because you don't have those things and you may not be able to predict what you need.
You don't have any friends left at JPL? You can hey, can I come visit?
That's a bit of a challenge, but you can't just because of it's government funded.
I'm not going to ask any questions. So for us, let's say anybody out here that's thinking about jumping into an entrepreneurial environment, what would you suggest you can do to enable yourself to thrive better in that environment?
So you definitely have to take everything with an open mind. You have to realize that there's going to be a lot of ambiguity, and you have to be comfortable with that level of ambiguity. And probably the only person who's going to fix that ambiguity is yourself, helping yourself and your teammates. And
Can you share an example of that?
Just in terms of how you would want to implement a specific system choice, for example. So I don't want to go into the details of the technology just because we've got some intellectual property associated with it. But a lot of my team is a younger team, and a lot of them actually don't have any systems engineering background. So part of that was me creating training material to teach them how to do traditional systems engineering. And so that was a way that I could leverage it's almost like a village, right? So you're a village, and there's the blacksmith, and then there's the the person who puts the shoes on the horses. And so me as the blacksmith in this example, I have to go out and actually teach other people at the company to be blacksmiths. So you have to be willing to be a teacher as well as being a leader in order to help a much smaller environment succeed and thrive. And which I actually think is a lot of fun, right? Because you can influence in a very positive way a group of people who would not normally have your expertise. So it's actually a really nice way of giving back.
We actually have someone who was a farrier, putting shoes on horses, who's now a manufacturer on the Art of Manufacturing recent episode. Cool. So yes, they still exist. And so what's the first lesson in being a systems engineer? If I open up your guidebook.
One of the ones that I loved, so Gentry Lee, who's like the Uber systems engineer from JPL, you can actually watch this video. It's like the top 10 traits of being a systems engineer, but it's understanding the sensitivities of the system. And so I'll give you an example. If something costs $1 billion and 750 million of that is related to, let's just say, the way the roads are laid out, and 100 million is related to the power system, and then some smaller quantity is related to everything else. If you were going to optimize the cost of that system, you focus on the chunk that goes along with the 750 million, not the chunk which goes on with the 50 million, even though that may be more interesting to you. So as a system engineer, you have to understand the sensitivities of the system. And so where you see a high sensitivity, that's the thing that you go after, whether it's to reduce cost, whether it's to reduce mass, or whether it is to reduce risk in the system. Is understanding those sensitivities and thinking about it in that way, in that connected way, is how you can actually make the system close and optimize the design.
Explain a little bit more about what you mean by sensitivity.
So sensitivity would be, one would be sensitivity to cost. It's really just a derivative, like if any of you have taken, calculus or or partial differential equations or something like that. So like if your civil infrastructure represents 3/4 of the cost to the whole cost, you would choose to go in and try to optimize that because it will save you more money.
Yeah. Okay, great. What do you do in your spare time? Your copious spare time?
So I don't have a lot of spare time, but on Sundays I fly. So I'm working on a new rating, my instrument rating. And then on the evenings I'm studying for my written test, which is a little boring for instrument rating. And then on Saturdays I go running or go motorcycle riding. And then I also have cats, so I take care of my cats. They're the number one priority.
Motorcycles and airplanes. Is there anything that you've learned as being in general aviation, being a pilot, that's relevant to what you've been doing at Hyperloop?
Oh, I would say so, because we were thinking, so one of the things our vehicle will do when it's going around turns, it actually will bank a little bit. And so we actually go to the FAA standards to what is the maximum bank angle, what is the maximum roll rate that you can experience from that, and that you would have a coordinated turn, which you have to have with a Hyperloop system or with an airplane. So there's a lot of the technology aspect and the way that you would actually, fly one of these vehicles, not as a person, but in terms of the autopilot would fly one of these vehicles that references general aviation. And another example would be the fuselage is basically like an airplane fuselage. So an airplane is a pressurized vehicle, and when it goes up to 30,000, 40,000 feet in altitude, it experiences a lower pressure environment outside. So it's very likely that when we come up with our production line vehicles, we will partner with an aviation provider to make that fuselage.
Tell me about your 16-year-old self.
My 16-year-old self. I was transitioning from Long Island, downstate New York, to upstate New York, which was very difficult. I remember having my Sweet 16 party, and then I was in a more urban environment going to literally the middle of nowhere. The town that I was going to was called Bovina Center. So the primary inhabitants of the town were cows. So I was in a bit of a transition of just like, how can I possibly deal with this change in my environment, having to get new friends? So what I did was I took up a new hobby. I took up snowboarding, because at least the one thing you can do in upstate New York is go snowboarding. So I did that. And then it was a little bit hard for me because I was definitely more of an urban person. So then I decided to graduate early from high school, and I did a lot more classes. And so I got out after 1 year and then moved up to Boston for college. So.
Yeah. And tell me a little bit about your family. How did they help you, maybe inspire you or change your worldview?
I have a sort of mixed race background. My mom is Scottish-Irish by descent, so she has red hair and freckles, and I have red hair and freckles as well. And it combined with my Indian self, because my dad is Indian. So my dad was a PhD mechanical engineer, so I had a real respect for his profession and the way that he would solve problems and the meticulous way that he would document things and draw diagrams. And so I kind of followed him around happily, saying, "Let me please help you fix this electrical socket and teach me how to fix the car." So it was just sort of like really looking up to that. My mom was an incredibly hard worker and very, very intelligent, and she had a background in languages, so she knew, I think, French, German, and some other languages as well, and so she would teach me the other languages. And my favorite thing that my mom taught me was never say can't, and there's no such word as can't. So whether or not it's something that it's difficult to do, that you personally find difficult to do, or something that other people say that you shouldn't do. So that has motivated me, I would say, my entire career. When anyone has said, "You really sure you think you can do that, or you shouldn't do that?" I'd be like, "Well, of course I can."
You can't say can't. It's like throwing down the gauntlet. I totally get that. It's like, oh, really? Let me show you.
Exactly.
So you have any advice that you wish you had known before you had gotten started that you'd want to share with everybody? What would that be?
Being down to earth and being a team player. You won't always experience that in life. When you experience people who either, try and do something to harm you or try to get in your way or try and defocus you, you should probably pick up on that and recognize that. And then if you can't make progress on that, then you should probably somehow, separate yourself from that situation or that relationship. So I think I have this personality where and I think this is a great thing to do. You always assume the best in everybody, but sometimes you have to move past people who might be an obstruction. And for people who are, minorities, and for women who are also an underrepresented group, you will face this a lot more because of that. You should actually be cognizant of that. It's better to know that ahead of time, that you're going to have a little bit more of a difficult time. And there's ways you can fix that and solve that, which is getting yourself mentors, expanding your network yourself, because it won't happen for you necessarily in the same way that it might other groups. So there are some challenges to be a person in a field who is of an underrepresented group, and acknowledge that and realize you got to arm yourself with different tools to be able to get through that, to be successful.
So interesting. I interviewed an entrepreneur, Felix Ajekam from Akash Systems, and he's doing this amazing diamond on gallium nitride technology that is enabling all this super high data throughput on satellites and all this stuff. And he's an African American who said that his parents they're from Nigeria, and they never wanted to tell him, they never told him growing up that there was any civil rights issues. Like, they couldn't even vote when they came to this country. And he had no clue. And then he went off to college at age 16 early. And all of a sudden he realizes he learns about this whole other world. And in some ways, though, he said that by not realizing it, he kind of just bashed through. But it was a bit of a rude awakening for him. Did you have mentors or anyone that sort of helped you through some of these, or were role models for you?
I did not. And I think I didn't understand that. That was my point, is that I remember sitting at a conference back in, maybe it was 2011. And there was a speaker, the keynote speaker, a gentleman, giving a presentation on all the different mentors that he'd had throughout his career, who opened this door and who opened that door and who taught him this and taught him that. And I sat in the audience realizing I've been working for over 10 years and I've never had a single mentor. And so that really hit me hard, that I thought that was normal, but it wasn't normal. And then, so what I did then was I actively went and sought out mentors. But there was like a mentoring in action program. But it's just, sometimes it can be more difficult because of it. And now what I do in terms of giving back is I actively mentor people because I want to make sure that other people who are like me can not have to face some of the hurdles that I face. So I do that by mentoring people myself.
I get the question a lot about, how do I find a mentor? And I'm wondering, maybe because you are one, how would one get a mentor like you?
In some companies, they actually will have mentoring programs. You literally can sign up. I'm part of this other mentoring program, which is for commercial space people. So I'm a commercial space mentor for a particular person who's been chosen. But you do also meet people in the course of your job. If you attend conferences, you can even contact people, via social media for advice. But oftentimes it's because you have a kind of personal connection. And then during the course of my being a project manager at JPL, that gave me exposure to a different level of the organization in terms of sort of the power structure of the organization. So there I was exposed to a whole bunch of project managers who actively wanted to help me and mentor me because I was new at what I was doing. But there is no simple path if a program doesn't exist in your institution. So you almost have to seek it out yourself.
Or if you're an individual.
Yeah, that's probably even harder. So attending events like this, and networking people and following up with them on LinkedIn or whatever social media means, or direct email, and finding people that you connect with, having coffee with them, that's another way to do it. So I do that a lot now, where I'll use LinkedIn and actually meet up with people for coffee or lunch or something like that to bounce ideas off. So that's another thing too.
Should they ask, will you be my mentor?
You could, you could for sure.
Forward. I get that sometimes, and it's a little bit tough situation, but I do want to ask, since we are at Art Center, which is an amazing place for transportation innovation, and most of the cars that are designed today are Art Center alum design. I mean, it's just really an amazing place. So we have an audience filled with creatives, creative entrepreneurs. What would you suggest people look at, kind of as your parting thought, of where are the greatest, most exciting opportunities that you think that this audience and the audience of the podcast might learn and think about?
So this is me. My personal philosophy is I've always wanted to, I guess, help people, but then I've also always been fascinated by space exploration. And so I think if you're motivated by something which helps society and solves a problem in society, by definition, that's ripe for an entrepreneur, right? Because if the solution doesn't exist and your marketplace is society, think of how much your return on investment is going to be. So I think if you could focus yourself on what are my particular skills, how can I use those skills, my strengths, to benefit society, and how can I turn that into an idea, into a product, into a service? And that's probably the nicest way of doing it, as opposed to thinking from the other side of thing is, where is there a gap in the market where I could make money from, right? So that's never been my philosophy, the monetary side. It's always been about how can I use myself to solve the problem. So the reason why I went to go work as an executive at Virgin Hyperloop One is that I knew that my engineering skills and specifically my systems engineering background for complex systems was a great fit for what they were doing. And I also wanted to expand into a woman in leadership, and I wanted to create the new form of green transportation. So that way I was able to take all of my skills, help society, and then innovate.
Really take your unique skills and curiosity, not just passions, to kind of pull them together into something that's unique to you, it sounds like.
Yes, I think so.
Awesome. So how can people connect with you, learn more about Hyperloop?
So you can find me on Twitter. I've been tweeting about this conference so far. So it's at Dr._Astro. And then you can also connect with me on LinkedIn. But yeah, I'm pretty active on social media. So you can even go to our Hyperloop One Facebook page or web page or Twitter feed, and you can actually learn about it that way. And we are in the process, we're about to start hiring again as well. So you should check out our website for the job postings, which are opening up.
Okay, so Hyperloop One?
Hyperloop1.com.
Awesome. Thanks for coming.
Don't go anywhere quite yet. We have time for maybe one or two more questions.
Hi, Dr. Anita. Hi, Z. This was really great for us as the design community to kind of figure out ways of how we can enter ourselves in these really unique, innovative spaces. As someone who's consulted with local and state government, especially in transportation offices, transportation at the local level is going through this ideas of equity, access, placemaking now. And so how do we use these prototypes and tests of Hyperloop One to address these large access and equity issues that transportation departments are going through across states and cities, especially in this political climate?
Are you thinking about equity? Is that part of your sort of agenda?
Oh, for sure. Yeah. So I think off the bat, because the ticket price is going to be a lot lower because the energy cost is incredibly low, it makes transportation over large distances a lot more affordable for regular people. And so we have a route that we're planning in India between Mumbai and Pune, where the bulk of the ridership is going to be just working class people. And it's going to facilitate, hopefully, an entire expansion of their economy because of all the induced demand of the people who can now live further away from the center of Mumbai and live in all these other places and get cheaper housing and things like that. So for sure, our ticket price cost by definition is going to be more akin to a rail ticket than a plane ticket. So it does facilitate that larger marketplace. In terms of how we use data, one of the ways that you justify any transportation system is based off of ridership and then based off of induced demand that you would actually benefit the economy around it. And then because Hyperloop is a new technology, it actually induces a new economic ecosystem. So there are many countries in Europe who are interested in implementing the technology, yes, to solve their transportation system, but actually to initiate a new ecosystem for new jobs associated with autonomous vehicles, associated with the design of these types of electromagnetic propulsion systems. So it actually helps people both from facilitating transportation, reducing carbon footprint, reducing congestion, as well as creating new jobs. And in terms of how we can share our data, anything related to the specifics of the design of a vehicle obviously is going to be our intellectual property, and you have to have ways to control your intellectual property so that you can continue to make money. But we certainly are working with governments around the world to figure out how we can bring in our systems with their local economy and partner with them.
Also, you said jobs. I also wonder whether new transportation technologies are going to enable us to, as a country, to compete when we have such high cost of land and housing shortages that maybe there's a way of tying that into bringing lower cost labor, frankly, to, connecting it with our urban centers.
It's true. And I think, where you do a technology development, you can do it all within one country. You can do it spread across the world. And that's the way that you can both create jobs and lower your own development cost if it makes sense. Because when you build an infrastructure or a transportation project in somebody else's country, it always creates jobs in that country. And labor jobs is one thing, but high-tech jobs, which ultimately is what this will do, is a great thing.
Training, that's another question, but we won't go down that path. We have another question over there.
Yeah, thank you for a great talk, and it's really great, inspiring conversations. So I just graduated from Arsenal a year ago. So I was wondering, do you set up a goal to where you are right now, or what's your next goal? Or you just I like engineer, I'm just taking every opportunity that was open to me. I'm just curious about your path.
Yeah, I definitely have not lived anything in a sort of pre-planned way. That's definitely a hallmark of who I am. My life is very serendipitous. And I think what I have done, though, is anytime a new opportunity presented itself, which seemed really unique, really exciting, made me go beyond my existing expertise base, made me challenge myself, that's when I took it. So I never want something which is easy. I want something which is hard, just like JFK said. I won't put on in his accent. But I think that was ultimately what I did was I wanted to challenge myself. I wanted to continue to grow. And I've had sort of 5-year career increments where I did launch vehicle development first, then I did communication satellite development with propulsion systems, and then I did Mars landing systems and Venus landing systems, and then the Cold Laboratory Atomic Physics Facility. And now I'm doing a transportation system. And so I literally I didn't seek out any of these opportunities. They kind of fell on my plate. But when it was really unique and really difficult, that was when I did it. So I think that's a good way to live your life because it allows you to expand your expertise into regions that you never would have thought possible. And as long as you're true to yourself and it goes along with your core values, then I think you're going to be really successful if you do that.
It's been a real pleasure talking with you. It's just you've had an amazing career and very inspiring things that you're working on. So thanks for sharing that knowledge with us.
Oh, thank you for having me.
Thanks for coming. Three of my takeaways were, first, a startup environment is definitely different from a large organization. If you're thinking of taking the leap, you should know what you're in for. Expect some ambiguity and fewer resources and infrastructure than you're used to. And often, for better or for worse, a shortage of established standards. On the flip side, you'll probably find an exciting culture where nothing seems impossible. Speaking of which, I like how Anita leverages the skills of the younger team members. So many people complain about millennials, it's become a cliche. But maybe we should get better at tapping into their strengths. She harnesses their ambition and fresh points of view. But meanwhile, because they lack experience, she plays the role of teacher as much as a leader. She creates training materials when needed and guides them to focus on the most important pieces, not just those that are the most interesting. And finally, Hyperloop One is at a very interesting inflection point in their history. They're transitioning from an early technology company to a full production system. This stage requires deep knowledge and attention to detail in safety, passenger comfort, reliability, regulatory issues, and more. That's where experience comes in so they don't reinvent the wheel. A transportation system as complex as Hyperloop doesn't come together by the seat of your pants. And a systems engineer like Anita, with an experienced leadership team and some structure in place, will be the key to make it all happen. Before we wrap up, I want to ask a favor. There's so many podcasts out there, it's hard to find the good content, right? So, if you like The Art of Manufacturing, please tell your friends and colleagues about it. And I want to thank everyone who've written recently with their feedback on our latest season. Jeff wrote in, "The Ventana interview was super fun. She gave me a high that lasted all day." Michelle and Mark each wrote in with their ideas to help Julio Ruiz of Liquid Sky Sports, whom we featured 2 weeks ago. By way of introduction to Julio, Mark wrote about the podcast, "I always like to give feedback on the spots I like and more on the ones I don't like." Don't I know it, Mark? Fortunately, Julio was in the latter category. And finally, Kim writes, "Thank you so much for the work that you do in putting the podcast together. I've learned so much from them. In particular, I love that the podcast dive deep into the details of the different pathways and hurdles to scale a company. They've really nurtured my entrepreneurial spirit and given me tangible ideas of how and when to strategically grow a company." And then Kim describes how she started a new company last year called Nomad Ice Pops. Kim, it sounds delicious, and congratulations. We can't wait to try them. Do you have some feedback? Message us on social media at artofmfg or write us at team@artofmfg.com. Time to wrap it up for The Art of Manufacturing. Tune in next Thursday when we speak with Lydia Yan, founder and CEO of Next Trucking. While Hyperloop has grand plans for the future of transportation, Lydia has created a platform that's making cargo more efficient today using our existing trucking infrastructure. For show notes, visit www.artofmfg.com. Follow our adventures on Instagram and Twitter at artofmfg. And to chat with other like-minded creators, join the Art of Manufacturing Facebook group. Never miss an episode. Subscribe on iTunes or Spotify or your favorite player. And if you like the show, do us a favor and leave us a review.
or send us a message with your thoughts and ideas to feedback@artofmfg.com. This podcast is produced by At Large and Dangerous in collaboration with Make It in LA and other partners. Visit makeitinla.org/connect to sign up for local LA events and news. A big shout out to Peter Brandenburg, the producer and audio engineer. Thanks for listening to The Art of Manufacturing. I'm Z Holly, and remember, don't just make it, make it.